So we're supposed to find the equation of the tangent line to the parametric curve given by the equation x is equal to this mess right here and y is equal to this mess right here, and we need it at time equals 1. So what we're going to do is note that 1, we don't know what the curve looks like. Okay, now we can graph it out, and I'll do that here at the end if we have time. But what I really am focusing on here is finding the derivative of y with respect to t, find the derivative of x, the rate of change of x with respect to t, and then taking the ratio. So we have the following. We have dy dx is equal to dy dt divided by dx dt. So we need to find each of these separately. So let's go ahead and work on y first. So dy dt is equal to 5t to the fourth plus 2t. Then we've got dx dt. So the rate of change of x with respect to t. So this right here is going to require the chain rule. So this will be 4 times the quantity 1 plus t to the third raised to the third power, now multiplied by the derivative of the inside, which is 3t squared, plus the derivative of 2t with respect to t is just, t squared with respect to t is just 2t. Just like that. Okay. Now we can go ahead and simplify this guy a little bit. So we're going to get 12t squared times the quantity 1 plus t to the third plus 2t. Now what we need is what are the x and the y values, or what is the point? Okay. The point value, and I guess we really don't need it, but it will help in the graph, so I'm gonna grab it anyway here. The question is, what's the ordered pair when t is equal to 1? Well, when t is 1 over here, I get 1 to the third, which is 1, plus 1 is 2, 2 to the fourth is 16, plus 1 is 17. And then here when I plug in 1, I get 1 plus 2 is 4. So this is the point right here on the graph. If y is a function of x, this is the point on the graph that we're concerned with finding the tangent line at. Okay. So we have to find the whole tangent line. Okay, so actually we will need this point. So what we need now is dy dx, the rate of change of y with respect to x, and we're going to be doing that at the point at x equals 17, but I'm going to write the ordered pair down here. Okay, so this is what we need, and we know that this occurs at t is equal to 1. So we have dy dt over dx dt. So dy dt is this guy up here, and dx dt is this ugly guy right here. Okay. Now this is dy dx, okay, and what we have is we have it in terms of t. Okay, we know that when t is 1, we have 17, 4. So we're going to go ahead and compute that. Okay. So this is going to be 5 times 1 plus 2 times 1 is going to give me 7 on the numerator. And the denominator, I got 1 plus 1 is 2, to the third is 8, times 12. So 8 times 12 is 96, plus 2 gives me 98. Now we should check to see if this guy can be reduced, and 98 is divisible by 7, and so that's divisible 14 times, so this will give me 1 over 14. So the slope is fairly is fairly flat. It's a 1 over 14 slope. And so what we were trying to do, if you remember, we're trying to find the equation of the tangent line. So there's some line out there, y is equal to mx plus b. So we've got y is equal to our m value. We would like to know what b is. So we're going to, at this point, we're going to insert our point 17 and 4. So 4 goes in for y, 17 for x. So this is 4 is equal to 17 fourteenths plus b. So 4 minus 17 fourteenths is going to be equal to b. So we need to get this guy over 14. And so that will be, I believe, 56. 4 times 4 is 16 plus another 40. Yep, that's 56. So this implies that 56 over 14 minus 17 over 14 is equal to b. And so 56 minus 17, well, 56 minus 10 is 46, minus 7 is 39 over 14. Okay. And so what we've got is our b value. So hang on one second, let me just write that over here. So our equation is y is equal to 1 over 14x plus 39 over 14. Now what we can do is we can check this all using a graphing program. So what I'm going to do is I'm going to bust out, let's see here, let's do Desmos. So what we're going to do in Desmos is we're going to enter an ordered pair with the equations for the parametric. So for example, x, let me go back up here, I'm grab my other computer. X is 1 plus t to the third raised to the fourth plus t squared. That's our x value. Our y value is t to the fifth plus t squared plus 2. So this right here gives us our parametric curve. And now we get to pick right here, we get to pick what t ranges from. So I'm going to go from 1 to 2. Okay. And we know that at 17 over, okay, we should be up at a height of 4, which it looks like we are right here. Okay, so this right here is time 1. Okay, it equals 1. In fact, if I go ahead and I change this just to 1, then that means that this endpoint right here is the point in question that we're looking for. Okay, so I'm going to extend it a little bit more. Now, let's go ahead and plug in our tangent line. So we've got y is equal to 1 over 14 times x plus 39 over 14. And if you notice, it looks very good here as far as being tangents. Whoops, right here at that spot 17.4. So it's just a nice way to go ahead and verify it. We could also use something like Wolfram Alpha to do the same verification, but I think this is good enough.